Did you know that just 1 ton of high-grade e-waste, like computer circuit boards, contains 100 to 300 grams of gold, which is actually more than what you get from 1 ton of gold, or, yes, you heard that right. And still, every day we dump thousands of tons of e-waste into landfills. When your phone, laptop, or TV becomes old, what do you do with it? Do you throw it in a drawer, dump it in the trash, or sell it to a scrap dealer for 500 rupees? But here's the shocking truth. These small devices are turning into one of the world's biggest environmental problems. And this problem is called e-waste. Today, we'll talk about how gold and silver are extracted from e-waste, how dangerous chemicals are separated, and what the latest technologies are for recovery. What is e-waste? So let's first understand, what exactly is e-waste? In simple words, any old or broken electronic item that we no longer use is e-waste. This includes phones, laptops, fridges, TVs, batteries, everything. And this is not a small problem. In 2022, the world generated nearly 62 million tons of e-waste. Just imagine, that's enough to build a pile as big as the Himalayas. In India alone, we generate over 3.2 million tons of e-waste every year. And the shocking part is, only about 20% of it is properly recycled. The rest? It goes into landfills, where toxic chemicals leak into the soil and water, polluting our environment. Why it's dangerous? E-waste contains heavy metals like lead, mercury, and arsenic. According to WHO, inhaling toxic fumes from e-waste can slow down brain development in children. Just think, the phone or laptop we throw into a landfill today could be the reason why children tomorrow suffer from stunted brain growth. This isn't just trash, this is slow poison. If these toxins enter soil or water, they can cause cancer, nerve damage, and kidney failure. And let's not forget, making electronics requires precious metals like gold, silver, copper, and palladium. When we dump e-waste, all of these are wasted too. In other words, we are literally burying money in the ground. Special bacteria, like acidithiobacillus ferrooxidans, are used. Through their natural metabolic processes, these bacteria dissolve metals from e-waste. Advantage: very low energy use, environment friendly. Drawback: slow process, can take weeks or even months. 5. Emerging technologies. Now, let's look at the latest technologies. Electrochemical recovery, passing electric current to deposit metals on electrodes. Supercritical fluid extraction, using high-pressure CO2 to extract valuable components. AI and robotics. AI computer vision and robotic arms automatically identify and separate valuable parts. This is the future of e-waste recovery: fast, smart, and efficient. Conclusion. So, the bottom line is, e-waste recovery is not about using just one method. It's always a combination of mechanical, chemical, biological, and AI-based techniques. Only with the right mix can we maximize recovery of precious metals and minimize environmental damage. Future and call to action. E-waste management is not just about technology, it's about our mindset. Recovery methods. Now let's talk about the most important phase of e-waste, recovery. This is where the real magic begins, because this stage decides how many valuable metals, plastics, and other materials we can get back. 1. Mechanical recycling. Here, e-waste is first broken down manually or by machines into separate parts: plastics, metals, glass, and PCBs, printed circuit boards. Then shredders turn them into small pieces. After that, magnets and eddy current separators are used to separate the metals. Advantage: simple, fast, and less energy intensive. Drawback: rare metals are recovered in very small amounts. 2. Pyrometallurgical processing. In this method, e-waste is melted at temperatures above 1000 degrees Celsius. Since every metal has a different melting point, heat naturally separates them. This way, metals like copper, gold, and silver are efficiently extracted. Advantage: fast and bulk recovery. Drawback: high energy consumption and pollution risks. 3. Hydrometallurgical processing. This is a more chemical-intensive method. Here, metals are dissolved in acids like hydrochloric acid, nitric acid, or cyanide solutions. Then, through chemical reactions, they're extracted back in solid form. Advantage: even rare metals are recovered with very high purity. Drawback: safe disposal of chemical waste is challenging. 4. Bioleaching. This is an eco-friendly but slow method. In the next 10 years, if we don't adopt recovery technologies on a mass scale, the mountains of e-waste will turn our cities into giant landfills. But if we enforce strong policies, hold companies accountable, and make every citizen responsible, then not only can we reduce pollution, but we can also recover billions of dollars worth of precious metals, boosting the economy. So what can you do? Give your old electronics to certified e-waste recyclers. Promote a repair culture. Stop upgrading phones every 2 years just for fashion. Spread awareness in your friends, family, and college. Because technology alone won't solve the problem, it will only work when we decide to use it responsibly. And if you found this video informative, share it, so together we can shrink the mountains of e-waste.